You're listening to the Seen and Solved podcast brought to you by Hubbard-Hall. Better results, less chemistry.
So welcome to this edition of Seen and Solved presented by Hubbard-Hall. I'm Tim Pennington, your host, and today I'm joined by Jameson Grout from Hubbard-Hall, and we're going to be talking about a pretty interesting topic, electro polishing. And not a lot of shops do this, not a lot of facilities do this. It's kind of a specialty, but something I really want to learn a lot about, and especially figuring out what are some issues that some electro polishers have and how they can fix it. So welcome, Jameson. Welcome to the program.
Thanks for having me. Electropolish, you don't see a lot of shops where that is their sole focus. It's definitely a process that's kind of an ancillary. It's an add-on. It's something they do. It kind of falls into that camp of, yeah, we do that too. So sometimes it doesn't get the attention it needs. And a lot of times just the operators and the engineers on site just don't have the experience that they need.
Let me ask you a quick question. I've often heard, and maybe it's just me, sometimes I confuse electropolishing for maybe passivation or some other type of, it seems like there's a lot of different phrases people use. Tell us exactly what it's doing.
Yeah, so you're totally right. It does get lumped in with passivation a lot. And I think it's mostly because they're both stainless steel processes. Passivation just being a nitric or a citric dwell, for half an hour or something that the mil spec's calling for. And they're kind of trying to achieve the same goal. Passivation solely kind of corrosion protection. Electropolish, it'll give you that, but normally there's a decorative aspect to it, or they're using it for intentional removal loss. It's like a deburring process sometimes. So it passivates in itself. It's building an oxide layer, but it's also conditioning the base material, and it's giving it a better appearance. So it's more involved. There's more heat, there's more current, more equipment, but they definitely are in the vein. They're in the same vein, and a lot of shops will do both.
Yeah, I see a lot of medical parts, a lot of very, very precise medical parts and precise parts in general, right? There's a lot of the parts I see sometimes that people are specializing in with that.
Yeah, we see a lot of scalpels, a lot of picks, that kind of stuff. Firsthand, most of my hands-on electropolish has been in aerospace. And that's actually when I first got involved. I was taking over a shop, and we were a nickel, copper, tin, gold plater, but we also had electropolish. And so coming in, it was something I didn't know a lot about. I had to learn on the fly. And, conceptually, I had always just thought about it as it's like reverse plating, right? The current goes the other way, but it's kind of the same thing. But I learned firsthand that there's a little more to it than that. So,
well, let's talk about that. Talked about as you've been going out now and seeing some people doing it. What are some issues they're having, which are maybe common, and then how are you helping them fix these problems that come with the electropolishing?
Yeah. So just in the last month alone, I've had a few calls with the same issue. And when I started at Hubbard-Hall last year, it was this time of year in the summer, and it was the same problem we were running into. And that's people are calling in saying, hey, we're running the bath and we're seeing some pitting. In one case, a guy hadn't run the bath in 6 months, and he just fired it up and put some parts in, and they just came out all pitted. And you can't always fix that. But came on site, took a sample, and as you see a lot, he didn't have any way to check the bath on site. And you don't need too much. This is not like something you titrate or anything like that. But one of the big things we're concerned with is the water content. And the bath it's pure acid. You use it as received. It's not cut with anything. So it's pretty viscous. And as you drag water in, it actually affects the performance. So in this case, I took a sample. The spec rev was low, and that's a big red flag. We got a lot of water in the system, whether it's from dragging in on parts, or I think what we run into in the summer is just that latent humidity in the air. You just start getting that pooling in the top, and you get water in there. And so one of the big problems he had going on was that they weren't running the bath hot enough. And you'll notice these data sheets, they'll have big ranges. They'll say 110 or 210 or something. And what does that really tell you? And people tend to run on the low side, right? Because they want to save power. They want to have a safer environment, that kind of stuff. But running in that 180, 190 range is helping to evaporate off some of that water. It's not boiling, but you're getting water out of the system at those temps. So that helps that water from growing. So one of the big things we did was we readdressed their heating. He got more heaters in the tank. He got it mixing a little better too, which helped, prevent some stratification. And he's able to get the water out. Sometimes you can recover a bath. Sometimes it's easier to just dump and start a new one. But
yeah, is it a lot of water that can get in and cause the problems, or like you said, even just the drag-in sometimes can actually offset the cause some issues with it? Really?
Yeah. So I mean, it's going to depend on tank size and part shape coming in, but if you aren't covering the tank on off shifts and it's in a humid environment, and even if you have sprays around it, it can just naturally grow some water in there and give you problems. But running at 180, that's kind of a rule of thumb, but that's usually enough to mitigate any of that drag-in concern.
Right. Well, you even said he hadn't run it in a while, right? Should it just start back up if there's not water in there? Just start back up, be okay, or is that?
If it was covered and you mixed it well, yeah, it should start up fine.
Gotcha. Interesting. Okay, great. So keeping water out, keeping drag out, keeping moisture, everything like that. Good. Second, tell us another thing that some people are having issues with.
So on the opposite end of the spectrum, we're talking about that spec graph being low from the water. Another common problem we have is people see etching in the base material, and normally, we'll come out, it'll be the same story. We'll take a sample, we'll take it back to the lab, and in that case, you may see the spec graphs going the other way. It's getting too high, and what that's telling us is we have metals in the solution. So, we're reverse plating, right? So the current's going the other way. We are dissolving small bits of metal. In some cases, we're trying to, right? We're deburring the parts. So you're always going to be growing metal in the solution. It's just part of the process. So eventually, and I think 3% is normally the rule of thumb, 3% iron. You'll see data sheets kind of say different things, 3, 4, 5. Some people will just talk iron. Some people talk total metals, which would also be chrome and nickel. But once you start to approach that point, you'll start seeing problems with some of the like the 400 series alloys. They normally display a little bit of etching first, and then 300 series you'll have problems with after that. So that's kind of your flag that you got big problems on the horizon. But as far as the metal's concerned, you really need to implement some sort of desludging procedure. And it's not like a full desludging like we're talking with phosphates or black oxide or anything, but just some sort of decanting schedule to be regularly removing material and then replacing with fresh material. Some places their drag out is enough, right? They never run into metals problems because they have cup-shaped parts and they're constantly pulling the solution out, and they can just run those baths for years with little issue. Other people are running parts with lower drag out. They need to implement either every couple months, they need to do like a big, third of the tank decant to get those metals down, or they need to be taken out, X amount of solution per amp hour, almost treat it like a plating bath, like a brightener add back system. So people go both ways. It's really up to the shop, but.
All right, Jameson. So we talked about too much water in the tank. We talked about problems with etching. Finally, what would be the third biggest problem that you're seeing out there with a lot of shops who do the electropolishing?
Yeah, so those first two problems, those are definitely things that we can sample the chemistry, come back to the lab, take spec graph, run it on the AA, and I can come back and tell you quantitatively, I think you have a problem, right? And I think I know what it is. But something else we run into is problems with the tank itself, the actual operation of the tank. So I'll tell you a story about a disc manufacturer I was at a couple months ago, and they called me up and they're saying, we got some etching, and they could actually check their own metals. So they said the metals are fine, but we're still having this etching problem. So I came out and I was looking at it, and whenever, I guess I'll talk about metal finishing in general, but whenever you have like a visual defect that's not uniform on a part, you kind of got to think, okay, it's probably not the solution, right? Because the solution's touching everything. So there's probably something else going on here. So, we like to talk about pretreatment. Let's look at pretreatment first. Was that affected area treated differently than the rest of the part at some point? And in this case, it really wasn't. So then you kind of dig in and you look at the system itself and we say, okay, what's different with this surface, right? And in this case, it had to do with distance to the cathodes on the side. So, we talk about current density and plating. I think people have a good understanding of how the current density map works. Electro polish, the map's a little different. And I won't really talk about the specifics of it, but the kind of the take-home message and the thing to really understand is that this is a line of sight process. So you got to look at those surfaces and how they're looking at the cathodes, and then kind of judge, is it the same? Because the big name of the game in electro polish is mitigating resistance in the system. Plating baths, some of them run at 5, 10, 20 ASF. It's a lot lower. Here, we're talking, a lot of people are like 144 amps per square foot starting, right? 150, maybe 200, maybe even up to 400, depending on what the parts are and what they're trying to do, how much they need to deburr, how quickly they want to do it. So we're talking higher amps. We're talking a 100% acid solution. So it's very viscous. This is very thick. And as the electro polish is working, it's actually getting more viscous at the site. It's not like a film, but the affected area is actually getting even thicker. So we're really trying to mitigate resistance. And so if you are really close to one cathode, right, if your anode bar in the middle is really close to one side, all the current's going to go out that side. And then you're going to see different appearances between the two sides. So and in that instance, it was just an operator had moved the bars a little bit, and it was enough for all the current to go out one side. So that was an easy fix.
So if it's not, like you said, if it's not a uniform problem hitting everything, you're probably got something in the tank that's a little bit off, right? A little bit that needs to be paid attention to, like I said, cathodes or however it is that's happening there.
Yeah,
right?
We got to try to figure out the geometry of what's actually going on and then what could lead to that defect. Another thing I've seen is the cables. Cables start building up corrosion. Well, now all of a sudden it may be easier for the current to go through one side, stuff like that. So.
Interesting. It's funny you talked about temperature and you talked about, some other things. I know I had a plater tell me one time, when it was temperature range or whatever the range they give them on the spec sheets, there's a lot of difference between a 5-iron, a 6-iron, and a 7-iron, right? They'll go from 5-iron to 7-iron. We're going to go different. It's the same way with temperature, right? Is that you're going to get different results unless you really dial it in and figure out what it is that needs to be done for these processes.
Yeah, and it's a conversation we have across a lot of processes, because you'll see a lot of data sheets who intentionally have large ranges because they're trying to house a large number of operations, right? They want to be a robust product that can work at a lot of different ranges, but it doesn't necessarily mean you're going to get consistent product throughout that entire range. So it's really on the customer to figure out where they fit inside that larger range. They need to button it up, and they need to, design their process to stay in there.
Yeah, and then you'll get some repeatability with that. Well, that's great. Great information. Like I said, we talked about too much water in the electropolishing tank. We talked about etching and how that may be a problem, and then the other problem with electropolishing issues is really what's happened to the tank, what's been moved around that might cause some uneven processes there. So good information. I appreciate that. Or anything else we need to talk about?
Well, just on the vein of talking about the equipment itself, this is a higher current application. So something I actually ran into personally when I was running a shop was the system I had inherited actually had some components that weren't sized properly, and it actually led to some serious problems with parts of the system overheating and that kind of stuff. So I think it's important for everyone to kind of look at their system, look at your cathode rods, your anode rods, your eyelets, and make sure everything is sized for the load coming through. You can read online about ampacity, make sure you're using copper bars, make sure the system can hold the current going through it and that the map makes sense, because there's some weird things that can go on. Things can overheat. I actually had a cathode once flip. It became I think they call it a dipole, but it became an anode. And then I had one cathode dissolving the other one, and we were chasing our tails for days trying to figure out what was going on. And it was just a math problem with the equipment itself. So easily prevented.
Right. Yeah. Well, electropolishing is hard enough. You don't need to do these complications. So, well, listen, I appreciate it. Good information, Jameson. Thank you very much for that.
Yeah. Thanks for having me.
The Scene and South podcast is brought to you by Hubbard-Hall. For more podcasts, visit Hubbard-Hall.com or wherever you get your podcasts. Be sure to like and subscribe, rate and review, and join us on social media. Produced by Awcast.